There are long-standing myths of a young African man who allegedly fell in love with a female chimpanzee. However, before we delve into the details of that story, we must first examine the scientific reality. We will begin by exploring the research behind the origins of HIV/AIDS and how the virus actually spread. Stay tuned as we will break down the myth and discuss that love story scene by scene at the very end of this video.
Ladies and gentlemen, welcome to this in-depth exploration of HIV and AIDS from a purely scientific lens. HIV, or human immunodeficiency virus, is a lentivirus within the retroviridae family that primarily targets the human immune system, leading to a progressive decline in immune function if left untreated. AIDS, acquired immunodeficiency syndrome, represents the advanced stage of HIV infection, characterized by a CD4 cell count below 200 cells per cubic millimeter of blood, or the occurrence of opportunistic infections and cancers. As of the end of 2024, approximately 40.8 million people worldwide are living with HIV, with 1.3 million new infections and 630,000 deaths annually, predominantly in sub-Saharan Africa. This script will delve into the virology, pathogenesis, and ongoing research, structured across 10 chapters to provide a comprehensive narrative. Understanding HIV scientifically is crucial not only for medical advancement, but also for debunking myths and guiding public health strategies.
The origins of HIV trace back to cross-species transmission from non-human primates to humans in Central and West Africa. HIV-1, the predominant strain globally, likely emerged from chimpanzees infected with simian immunodeficiency virus, SIV-CPZ, while HIV-2 originated from sooty mangabes, SIV-SMM. The virus entered human populations around the early 20th century, with the first recognized cases of AIDS reported in 1981 among gay men in the United States, presenting with pneumocystis carinii pneumonia and Kaposi's sarcoma. In 1983, Luc Montagnier and Françoise Barré-Sinoussi isolated the virus, initially called LAV, lymphadenopathy-associated virus, while Robert Gallo independently identified it as HTLV3. The name HIV was standardized in 1986. By the 1990s, the pandemic had claimed millions, but the introduction of antiretroviral therapy, ART, in 1996 transformed HIV from a fatal disease to a manageable chronic condition. To date, HIV has caused over 44 million deaths, underscoring the urgency of continued research. HIV is an enveloped spherical retrovirus measuring about 120 nanometers in diameter, with a lipid bilayer envelope derived from the host cell membrane. Embedded in this envelope are trimers of glycoproteins, GP120 surface unit and GP41 transmembrane unit, which mediate cell attachment and fusion. The viral core is a conical capsid composed of approximately 2,000 copies of the P24 protein, enclosing two identical single-stranded positive sense RNA genomes, each about 9.7 kilobases long. These RNA strands are bound by nucleocapsid protein, P7, and accompanied by essential enzymes. Reverse transcriptase for RNA to DNA conversion, integrase for genome integration, and protease for protein maturation. The matrix protein P17 surrounds the capsid, stabilizing the virion. A dense glycan shield on GP120, comprising over half its mass as N-linked high-mannose glycans, evades immune recognition. This intricate structure enables HIV's high mutation rate and persistence in the host. The HIV genome encodes 9 genes: structural, GAG, POL, ENV, regulatory, TAT, REV, and accessory, VIF, VPR, VPU, and F. GAG produces core proteins, POL encodes enzymes via ribosomal frame shifting, and ENV yields GP160, cleaved into GP120 and GP41. The genome features long terminal repeats, LTRs, for transcription control, and elements like TAR, TAT binding, and RRE, REV binding. Replication begins with GP12, zero binding CD4 in co-receptors, CCR5 or CXCR4, triggering GP41-mediated fusion and capsid release into the cytoplasm. Reverse transcription generates double-stranded DNA, prone to errors at a rate of 3 to 4.1 times 10 to the power of -5 per nucleotide per cycle, fostering genetic diversity. The pre-integration complex enters the nucleus, where integrase inserts the provirus into host DNA. Transcription yields full-length RNA for packaging or spliced mRNAs for proteins. Assembly at the plasma membrane involves GAG-POL and RNA dimerization via the packaging signal, PSI. Budding and protease maturation complete the cycle, with recombination during reverse transcription enhancing variability. HIV transmission occurs through exchange of infected bodily fluids, blood, semen, vaginal secretions, and breast milk. Primary routes include unprotected sexual intercourse, anal or vaginal, with higher risk for receptive partners due to mucosal exposure, sharing contaminated needles among injection drug users, mother-to-child transmission during pregnancy, birth or breastfeeding, and rarely through blood transfusions or occupational needle sticks. The virus spreads efficiently in early infection when viral load peaks. Notably, individuals on effective ART with undetectable viral loads, U equals U, undetectable equals untransmittable, cannot sexually transmit HIV. Risk factors amplify transmission. Concurrent STIs, for example, syphilis, herpes, high viral load, and behaviors like multiple partners or substance use. HIV cannot be transmitted via casual contact, saliva, or insects, as the virus requires direct access to CD4+ cells and does not survive well outside the body.
HIV pathogenesis involves progressive immune depletion, targeting CD4+ T lymphocytes, macrophages, and dendritic cells.
HIV pathogenesis involves progressive immune depletion, targeting CD4+ T lymphocytes.
Advanced disease, or AIDS stage 3, occurs when CD4 counts fall below 200, leading to severe opportunistic infections like tuberculosis and malignancies such as Kaposi sarcoma.
Macrophages and dendritic cells. Acute infection, stage 1, features high viremia and flu-like symptoms, fever, rash, lymphadenopathy, within 2 to 4 weeks, with viral load reaching millions of copies per milliliter. The asymptomatic chronic phase, stage 2, lasts 8 to 10 years untreated, with gradual CD4 decline from normal. 500 to 1,500 cells per cubic millimeter to below 500, allowing opportunistic infections. Advanced disease, AIDS, stage 3, occurs when CD4 falls below 200, leading to severe illnesses like tuberculosis, cryptococcal meningitis, pneumocystis jirovecii pneumonia, and malignancies such as Kaposi sarcoma or non-Hodgkin lymphoma. The virus induces apoptosis in infected cells, bystander cell death via immune activation, and reservoir formation in latent proviruses evading clearance. Genetic factors like CCR5, Delta 32 mutation confer resistance in some populations.
Monitoring involves viral load and CD4 counts. Point-of-care tests enable same-day results. Genotyping guides therapy by detecting mutations.
Diagnosis relies on detecting HIV antibodies, antigens, or nucleic acids. Rapid tests provide results in 20 to 30 minutes, but confirmatory assays, for example, Western blot or nucleic acid tests, are essential. The window period, up to 28 days post-exposure, may yield false negatives due to delayed seroconversion. For infants, virological PCR testing at birth or 6 weeks is standard. Monitoring involves viral load quantification, target undetectable less than 50 copies per milliliter, and CD4 counts to assess immune status. Advanced tools like point-of-care nucleic acid tests enable same-day results. Resistance genotyping guides therapy switches, detecting mutations in reverse transcriptase, protease, or integrase genes.
First-line therapy often uses dolutegravir-based regimens for superior efficacy and/or tolerability.
There is no cure for HIV, but lifelong ART suppresses replication, restores immunity, and prevents transmission. Regimens typically combine 3 drugs from classes: nucleoside/nucleotide reverse transcriptase inhibitors, NRTIs, for example, tenofovir, emtricitabine, non-nucleoside RT-is, NNRT-is, for example, efavirenz, protease inhibitors, P-is, for example, darunavir boosted with ritonavir, integrase strand transfer inhibitors, INST-is, for example, dolutegravir, and entry inhibitors, for example, mariviroc. First-line therapy often uses dolutegravir-based regimens for superior efficacy and tolerability. Long-acting injectables like cabotegravir and rilpivirine allow monthly or bi-monthly dosing. Adherence is critical to avoid resistance. As of 2024, 77% of diagnosed individuals are on ART, with 73% virally suppressed. Management of advanced HIV includes prophylaxis for opportunistic infections.
There is no cure for HIV, but lifelong ART suppresses replication, restores immunity, and prevents transmission.
Prevention encompasses behavioral, biomedical, and structural approaches. Condom use, harm reduction, clean needles, and male circumcision reduce risk by 60 to 70%. Pre-exposure prophylaxis, PrEP, with oral tenofovir/emtricitabine, or injectables like cabotegravir every 2 months, or lenacapavir twice yearly, prevents acquisition in high-risk groups. Post-exposure prophylaxis, PEP, within 72 hours averts infection after exposure. Mother-to-child transmission is nearly eliminated with maternal ART, rate less than 1%. Vaccine development remains challenging due to HIV's variability, but mRNA platforms show promise in eliciting broadly neutralizing antibodies. Global strategies aim for 95-95-95 targets, 95% diagnosed, treated, and suppressed by 2030.
As of 2026, research focuses on long-acting therapies and cures. And for cures, we have shock and kill.
As of 2026, research focuses on long-acting therapies and cures. Twice-yearly lenacapavir for PrEP demonstrates superior efficacy, with trials exploring once-yearly formulations. Resistance to lenacapavir emerges rarely but often impairs viral fitness. Cure strategies include shock and kill to activate latent reservoirs, followed by immune clearance and stem cell transplants, for example, Berlin and London patients. mRNA vaccines target conserved epitopes for broad protection. Gene editing with CRISPR aims to excise proviruses or confer CCR5 delta 32-like resistance. WHO's 2022 to 2030 strategies emphasize equity, with goals to end AIDS as a public health threat by 2030. These advancements herald a future where HIV could be eradicated, but challenges like access and stigma persist. Thank you for joining the scientific journey.
Kofi was 23 when he returned to the forest where he was born, a place where the air smelled of rain and red earth, and the trees whispered in ancient tongues. He worked as a junior caretaker at a wildlife rehabilitation center on the edge of the Congo Basin, helping injured and orphaned animals find their way back to life. That was where he met Ayo. Ayo was a young female chimpanzee, rescued after her troop had been scattered by illegal logging. She had intelligent amber eyes and a quiet presence, watching the world carefully, as if deciding whether it deserved her trust. Unlike the other chimpanzees, she never screamed or threw fruit. She simply observed, especially Kofi. At first, Kofi thought nothing of it. Animals bonded with caretakers all the time. But weeks passed, and something deeper formed between them. When Kofi sat near her enclosure, Ayo would come close and rest her hand against the glass. When storms rolled in and thunder cracked the sky, she grew restless, until she heard his voice. Kofi began to feel something he struggled to name. It was not desire. It was not ownership. It was love, the kind that arrives quietly and changes how you see the world. Through Ayo, Kofi saw intelligence that mirrored humanity, emotions that crossed species, and a fragile connection between humans and nature that had been broken for too long. He spoke to her about his dreams, his fears, the city he left behind. Though she could not answer in words, her eyes responded with understanding. But love, Kofi learned, is also restraint. As Io healed, the day came when she was ready to return to the forest. The center prepared her release with celebration, but Kofi felt his chest tighten. Keeping her would be easier, safer. She trusted him. Yet true love, he realized, is not about holding on. It is about letting go. On the morning of her release, Kofi walked with her deep into the forest. When the gate opened, Ayo paused. She turned once, met his gaze, and touched his hand lightly. Just a moment, brief and wordless. Then both Kofi and Io stare into each other's eyes. Slowly Kofi get closer to her, hugs her, start kissing, and both did the unthinkable. After the unthinkable intimacy, she disappeared into the green. After a few days, Kofi got sick, and later on doctor discovers a virus known as HIV/AIDS, but that virus had already spread into many people. Sometimes while walking beneath towering trees, he would hear movement in the canopy and wonder. He never saw Ayo again. But the love he felt, for her, for the forest, for life itself, never left him. And in that way, it was enough.
If you have not subscribed my channel, hit the subscribe button, like button, and turn on the notification bell for more informative and entertaining videos.